For the record, today we're going to do calling a spontaneous class that looks at the issues related to Hurricane Ian, but it makes also for a good case study in the use of GIS for disaster management and to show you guys what you're learning in this class, how it can be applicable to kind of current events. So if you look at the slides that are here, we're still sort of in this sort of area on the left of this figure, Python concepts, VS Code, and we're going to really use ArcPy a lot more today. So that's kind of where this is at in the big picture of the class. And really, you could think of it as leading to algorithm construction, or at a minimum, maybe calling it a workflow, right? So, so right now, when this, I'm recording this, it's September 29th, 2022, and we are currently facing Hurricane Ian. Raise your hand. Do any of you have family members or connections to Florida? Anybody know anybody down there? Yeah. If you're, I don't know, your generation, are you guys still into Facebook? What does your generation do? Like Instagram? I don't even know what nowadays. What's cool for you guys, if social media wise? Instagram? Yeah. TikTok? Nothing? You all have flip phones with just, old school texting because the government can't track you, right? Well, for me, I'm on Facebook, and I've been seeing lots and lots of people my age and older now, they're moving to Florida. They live in Florida. My brother, who's a couple years older, he has a house in Florida. He still lives in Rochester, but where I'm going with this is Florida's getting hit by Hurricane Ian. It's the thing happening this fall. A lot of people have been posting about what's going on down there. Yesterday, it was particularly bad. This is what you're looking at is a grainy kind of screenshot from NOAA, the National Oceanic Atmospheric Administration. So that's what's happening in Florida. Now, when disasters like this happen, they're fundamentally spatial, right? A hurricane is coming. You have to predict where it's going to go. It's going to make landfall, and it's going to start impacting people's lives. And you need to know where they are and there's lots and lots of things that have to go on when a hurricane like this happens. You're probably hearing about like Red Cross deliveries or whatever. It's all spatial, and it's all driven by GIS. I wrote a whole entire book called GIS for disaster management. So this is kind of an area that I've always been interested in. So let's give you a little more background. So what we're going to do in class today is try to answer using coding the basic but important question: how many people will be impacted by Hurricane Ian in Florida? And what I did for you in class today, I went and got 2 data sets that I curated and put them into easy to use formats for what I wanted to do in class today. The first one, if you're curious about this stuff, is this one here. National Hurricane Center and Central Pacific Hurricane Center, NHC data in GIS formats. So if you've never heard of these organizations, NOAA is the U.S. federal government. The National Hurricane Center is also through NOAA and the U.S. federal government. And these are the people that are tasked with the official use of data, amongst other things, when big events like hurricanes that are hitting Florida. So if you look at, advisory forecast track, cones of uncertainty, wind, arrival time, and so forth, they publish this data in GIS formats. And in this case, SHP. Hopefully by now, after 6 weeks, you guys know what a shapefile is. They give you a shapefile with different data formats about the hurricane. Okay, so that's one data set we're going to use. The other, actually, these are my slides. They're just probably easier for me here to do it this way. Is this from the U.S. Census Bureau? Have any of you ever downloaded data from the U.S. Census Bureau, just out of curiosity? Yeah, you have? Okay, well, what have you downloaded? For which class? Oh, perfect, great. Yeah, that's right. If you like data, and that sounds like a perfect thing for a class like Principles of Data Science, get ready for all the data you can possibly handle, because this is its own big can of worms kind of here. Is finding data through the U.S. Census Bureau. So why did I do that? Like even right here, just looking at it, their graphic, try, grocery stores in Georgia, right? So for this case, I wanted to know back to this, how many people will be impacted in Florida? Well, I need to find out population numbers to do that, right? I have this data set here that tells me where the hurricane's going, but the Census Bureau, which collects data on the US population to excruciating levels of detail, can give me, I would call it reference information about who is living in Florida. And if you take a class on data science, the Census Bureau has all kinds of what they would call indicators. How old, just the general age of people. Are they over 60? Are they over 65? Their race, their education level, type of housing, and on and on and on. It's really pretty overwhelming. And it's not necessarily very easy to take data from there and get it into GIS. So that's what I did for you. So that's what I did yesterday. I put together some data sets that we can use for this assignment without spending multiple class periods on more of just using GIS tools for data processing. If you take some of the other classes, like in the GIS immersion or major, you'll get in more to this kind of stuff of like doing what are called table joins, cleaning up data, importing CSV files. I didn't want to deal with that. That's not what we're interested in for this class. We're interested in algorithms and coding and all that. And you could use code to do all those things, but I just got them put together. So this slide kind of shows you what we want to do. We're interested in this red, what you see here, this red line is the hurricane trajectory as of yesterday, and all the polygons that are in purple are the population of what are called census tracts. Raise your hand if you've heard of a census tract before. What's a census tract?
It's like an area that they like measure the people in. That's a bad way to explain it.
The area they measure the people in. Yeah, that's a sufficient answer. That's fine. We'll look at them in a second. But census tracts are basically when they do the census, they break sort of geography up into small units, spatial units for counting people. So they're much smaller than a county, and they can give you a much better sort of granular representation of population or something underlying in a given area, right? And in just a moment, we're going to look at the census tracts for that I got for you here. Okay. So here's what we're going to do. If our back to our question is how many people will be impacted by the hurricane in Florida, the steps to do that are this. And I'll show you how to manually do it with button pushing. And then what we'll really do with the class is code it all out. Okay. So that's what I would argue is what the real benefit of this class is giving you is we're going beyond just driving the software through using the graphical interface. And for most cases, that's fine. But, the idea of computational thinking, if you can really think through all the steps to do something and have it done in code, you can then build more robust analytical tools that can go way beyond what we're going to be able to do in about 50 minutes of coding together. Okay. So let's get this thing set up to start. We'll do it manually, and then we'll jump over to VS Code and code it out. Okay, so you should have on your C, well, at least on my case, I put it in CTemp, the week 6 class data sets. So go ahead and open up ArcGIS Pro. And what I'm going to do is, here's a little trick that I like to do. If my stuff is in CTemp, wherever you downloaded it, and then the 6B data sets, it's this folder here. I'm going to, at least the way I'm going to do, I'm going to go to my Windows Explorer, copy that directory, and then I'm going to go to ArcGIS Pro, make a new map. I'm going to paste that location in. I'm going to uncheck create a new folder, and I'm going to call this one 6B Ian. because it's class 6B for Hurricane Ian. And what that's going to do is just create a new project right in that same folder where the file geodatabase is. So it's right there and ready to go. And we're also going to be using that location in our code when we do that in just a second. Okay. So I'm going to hit OK on there. And if I go now over to my folders, I should see this Hurricane Ian FLGDB, and that is a file geodatabase that I gave you, I provided for class today. So that's why I did it. So I wanted to get right at the data. So I set my project up right in that same folder as I did here. And if if you can see it, here it is, the APRX from 8/16 is the time when it just happened. Okay. Did everybody get there okay with just that setup? Okay, great. So what you want to do then, if you haven't already, go to Hurricane Ian FL, click the little expansion triangle, and grab FL census tracks with WP, with POP. And then Hurricane Cone 28 September. All right. So it's something like that. You can save your work. And now let's change the symbology a little bit just for a little refresher. If you want to make it look the way like I had it here, right? So I have the hurricane cone is no fill with probably about 1 or 2 point red line symbol. And so to do that, if I go, and mine is pink, or maybe salmon is a more cool way to describe it. My salmon colored thing. If I double click on that hurricane, it goes to the symbology. I'll just click on black outline to start. And just by doing that, it takes the fill out. And then if I go here to properties, you can see the color is transparent. I'll make the outline color red. I'll make it maybe 2-3 points. Hit apply, and then that's how it looks like that. You don't have to do that. Yep.
How did you get the thing to drag over?
So we had a question about how to bring the data layers over. I expand that out. I grab the. You could maybe.
Mine doesn't expand.
It doesn't expand. Okay, let's see. Okay, yeah. So we got the cone, and then for the census tracts, zoom in just if you take a look at them. There's a lot of them, right? If you were to turn off the census tracts just to look at what they underneath. Like St. Petersburg. I'm not really too versed in the details of Florida, but St. Petersburg's a coastal city, real dense population there, because waterfronts tend to be, the more dangerous it is, the more attractive it is for people to live there, right? Because the water's so nice, but when the storm surges come. But if we turn on the census tracts, you can just see there's a lot of spatial detail, even within like neighborhoods of, look at all, it's a pretty dense area here. There's a lot of census tracts there. So that's why census tracts in general can be a really good data source when you really need to know precise kind of things versus a zip code or a county. Now, if you were to right click on that Florida census tracts with POP and do attribute table, what I did was I took the underlying census tracts, grabbed the census data, and then joined on the population in each census tract. And that's a real big can of, it might be maybe not so clear to like how to appreciate that, but that's its own skill to learn with GIS, is how to manage data, just to bring it in, join it, clean it up. I was going to give you guys the full census data to see how ridiculous it can be, but all I wanted was the population, right? So that's what we're going to work with. So I'll close that. Excuse me. I'm going to right click and just zoom to the layer here. And then I'm going to right click on that layer again and do symbology. And then instead of a single symbol, I'm going to do graduated colors. And I'm going to use, if I go under the fields, I'm going to use population. And maybe I'll change my color scheme to make it look like I did I used purple in the slide picture. But there it is. I've just recreated sort of what I showed you in the slide. Coding wise, it doesn't really matter what it looks like, but just for learning about GIS a little bit and just kind of getting a sense of this. So what we want to know, back to the original kind of mission here, we want to know the population of everybody that's sort of inside of the red polygon, right? That's one of the most basic things that decision makers are going to want to know. Okay, we have a hurricane coming. How many people are going to be affected by it? If it's 100 people, well, that's the local people. If it's going to be 1 million people, that's a much bigger situation to have to deal with. And this is one of those bigger situations. This is going to be, you think about a disaster. You've got the local people in the counties, the state level, the federal level, volunteer groups. This is going to be a big one. And GIS drives all of it because it maps and showing what's going on is fundamental to it. All right. So everybody good with that? Just the setup so far? Got the data sets? Yep. Okay. All right. So if we go back to what I had in here, if our goal is to find out how many people are affected by the hurricane, you can answer that question just using the software. And let's do that to show you. And then we're going to do the same process in code. All right. So steps to compare the manual to coding automated. So first I want to really do this. Select the census tracts within the hurricane path. Okay. And if you do that, we're going to go here, go to analysis. So click on the analysis tab, tools, and then type in under geoprocessing, select by location. Okay. So that's the tool. And all these tools, as we've seen before, they all have like a Python equivalent. Okay. So the input features here, if we look at the help for this, and I put a reference to this, by the way. They don't have a picture. But basically, this is where one geometry is used to select from another geometry, all right? So if the input feature is going to be the hurricane cone, okay? And we want to say, give me all of, then with the hurricane intersecting, I want to select from the census tracts, okay? And that's all I need to do there, just those two. So I'm telling it, give me all of the census tracts that intersect with the hurricane cone, okay, in this dialog. And I'll do it, I won't, these other things are just optional parameters. So when I hit run, I did it incorrectly. I got it mixed up. So let's see here. I guess I got it backwards. We want census tracts that intersect the hurricane cone. I apologize for that. Let me see. That should do. Yeah, there we go. That's better. Sorry, I had the two mixed up. So if you just read through it in verbose English, I want to get all of the census tracts that intersect with the hurricane cone. And when I did that, notice all the blue in the census tracts. If I turned off the cone for just a second, notice how there's like purple and there's like lightish blue. Did you guys get that out there? Did that work? Yeah. Okay. And then if I were to right click on the census tracts and go to attribute table, if you look down here in the bottom middle there, 1752 of 5,160 were selected, right? So that gives me now the census tracts that are going to be impacted by the hurricane coming through. Okay, and that's a real basic GIS but powerful option. Select layer by location. All right, so that gives me that. But now I need to give a report to the governor or whoever. Well, how many people is that? Right, that's one thing. I'm not going to necessarily, I need to basically now get sum up the column population of the selected records, okay? And if for the manually, then we're going to take the selected census tracts. Let's say we want to make them their own new layer to look at. We don't need to look at all of the census tracts. So one thing I could do, I don't know why that's there. When you have like you can take you have about 1,700 of 5,000 were selected. You can take that subset of records and export them into their own new table, all right? And the way I'm going to do that is if I right-click with my selection, right-click on it, do Data, Export Features. And so I'm going to take Florida census tracts with population, and I'm going to send them out as a new feature class. And it's fine actually just to use the default. It is going to put it in the project file geodatabase, but we'll just take the defaults. It's fine. So I'm going to take this subset, write it out to a new feature class in this particular file geodatabase, and hit OK. Okay. And so if I turn off the original one, you can see this kind of chunk of data here, chunk of census tracts that again are, you can maybe see it a little more clearly now. So those are all of the population census tracts that are in the pathway of the hurricane, okay? And what I just did was exporting it. If I go back over to catalog and I look in here, the default geodatabase, there's what that command I just ran sent that out. All right. If you're following along, did that work for you? Right. I mean, it's not hard to do. It's just knowing where to find the tools and sort of what things to click. Okay. And then summarize the count of the population impacted. And let's see. To do that, we're going to use another tool. Yeah, I was just trying to remember. So we're going to use this tool, the summary statistics, which I believe if we take the name of that, go back over here. Yeah, summary statistics. Calculate summary statistics for fields in a table. Okay, so I'm going to use this tool now to do a summary of the population, right? So again, I'm going to look at, I want to take the record from this table that got created that I first selected it, then exported it, and now I want to get a sum of all the values in that column there, population. And there's actually a couple of different ways you can do that, but this is the way I'm going to show you how to do it. So the way this tool is going to work, I'm going to do input table is going to be FL census tract export feature. And then what this tool does, it's going to create a standalone table with the whatever statistic I'm looking for. So in this case, I want to go to the field population, and I just want to sum. I want to just sum up all the numbers in the population field. And it's going to put the table it creates in my project file geodatabase. Maybe I'll change the name here and call it pop impacted. Okay. So when I run that, okay, you always want to look for green. If you go over to catalog, so I called the table pop impacted, and there's a table now that just got created called pop impacted. And then if I drag that, actually it already put it in the map for me. If I go over here to standalone tables on the bottom left of the screen, and I right click and do open, there it is. There were 1,752 records. The sum of the values from the population column, it's not formatted, about 7 million people. 7 million, I'm reading that right? 7,800,000 people about. That's a lot of people. You know, so that's, if you look at all those records, you know, and they all add up, that's a pretty big deal. 7 million people, right? So that's what they have to deal with, and that assumes the hurricane's not going to change. And keep in mind, it's going to keep on. Look where it's projected to go. Coming up next in a couple days, it's supposed to go out into the ocean, turn west, and then hit the coast again in Georgia, right? So tools like this are important for, like, a, you know, they call it situation awareness, know what's going on. Okay, so that was the end goal. We got there by you know, getting some data sets, running a series of tools, and this gave us our final number. So now we report, you know, you're on your co-op with the Florida State Department of Emergency Management as a GIS intern, and here's your answer you give to the decision maker, right? I mean, this is what people do all the time. Did everybody get to that point okay? Yeah. Sure, what you need? The what's that? Oh yeah, all I did, I mean, I just clicked on it. I didn't really. So what I did was, did you get the features exported? Yeah. So all I did there was, I right clicked and just did attribute table. Then I scrolled over and I just clicked on the column heading. I didn't necessarily select anything. I just kind of clicked on it. Is that what you're asking? Okay. Yep. And from there, so with the exported table, then I just I used a tool called summary statistics. So I put summary statistics in. I clicked on it comes up as the first thing, and then the input table was the exported features. I changed the name of the output table to population impacted, and I picked population, and then by default it just gives you a sum, and that's what that was.
And how do you see that sum? When you have it?
Oh, once it runs, yeah, you should then, once it runs, it automatically, on the very bottom left, right down here, says, it should say standalone tables, and then pop impacted, and then you right click on that and do open. And then it's a real simple table with just one row. It's just the output of that sum. Yep. Okay. Did everybody get to that point? Okay. All right. So, you know, like I said, that works good. You know, if you know how to really drive the software by using the GUI, that's great. But however, you could do all of that workflow with, I don't know, maybe like 10 lines of code. You know, you could put yourself out of work, or, you know, put somebody else out of work by writing code to do all of that. If there's a known thing, and think about it, like every day, if the hurricane is changing, you might want to have some automated process that's constantly giving you updates on where the hurricane is going, its trajectory, and so forth. It may not even really be feasible to sit there after manually do this all the time. This could all be automated. And this is just one part of it, you know, creating a map as a report and so forth. But like I said in the beginning, just for the sake of time in one class, I thought this would be a manageable thing. So far so good. I don't know if, hopefully you find this interesting, but let's code it out now. Let's do this whole process in code. And so to do that, let's fire up VS Code. And what you should do to start with is right out of the gate, point your folder, your working directory of VS Code at where you put your ArcGIS project. So what I mean by that is, so I put mine in C, temp, 6B datasets, and there you can see like all my stuff from ArcGIS Pro. So I'm going to select that folder. And there's just a bunch of junk in there, sort of not really related to VS Code. And let's out of the gate, then let's create a new Python file. So I'm going to go to File, New File, and I'm going to call it, so again, I'm writing my, I'm going to call it, I'll call this Ian analysis.py. Create file. And just to make sure it's working correctly, you should see the Python kind of logo, so you have the right file type. Now, do you guys remember last class how we pointed the Python interpreter to ArcGIS Pro? Do you remember how we did that? All right, for today, we don't need to use the clone environment. We're just going to use the straightforward ArcPy. Could anybody remind me how I do that? Just for see if we remember how we do these things? Yeah.
Is it Control-Shift-P?
Yep. Right, exactly. So I'm going to go Control-Shift-P, and then it should be Python select interpreter. And now in mine, of course, I've got lots of stuff in here from class. I haven't cleaned up my mess. You should have one. Do you guys still have your clones from last class? Are they still there? I don't know on the house computers if they go away. So the clone or the default ArcGIS Pro should be sufficient. All we're going to use is ArcPy. We're not going to bring any special libraries in or anything like that. So just point your Python at that. Okay. And you'll know right out of the gate if it's working. So we're going to by the way, can you guys see that okay if you're going to watch me type? I'm sorry that this screen doesn't want to work. Can you see the code okay? All right, just want to make sure. All right, so straight out of the bat, we're going to import. And looking good, it's showing up. And there should be no yellow squiggly lines. If you have a yellow squiggly line under that one line of code, something's not right with your import. Everybody good with that at least at a minimum? This is one of these fragile house of cards. If that's not working, a lot of other things are not going to work. We all good there? Okay. All right. So this is also going to be kind of important. Next, we're going to set up the workspace. Whoop. And so here's what we're going to do. So we're going to type in ArcPy and then enter and env. And because ArcPy is plugged in, it's filling in things for me. So we're telling it we want the environment workspace. Doesn't seem like that wants to fill in for me. Is equal to, and then we're going to use, for this, basically what we're going to do here is tell ArcPy that all the data operations are going to happen in this one file geodatabase. So in my case, it's going to be this. I'm going to have everything happening in this file geodatabase, which behind the scenes, this is all the internal plumbing of a file geodatabase, but it looks like a folder icon. But the way I'm going to do it is like this. I'm going to copy that directory path. I'm going to do a raw string that we learned about, R, and then I want the name of that. So what I do is this is just the way I do it. I like to right click on the file geodatabase, rename it, start renaming it, Control C to copy its name, and then click off in the white. I'm not actually renaming it. I'm just too lazy to try to type that in because I know I'm going to get it wrong. So I copy that, and then I put a slash here, and I got something like that, okay? So all I did was a raw string to the full path of the file geodatabase that I gave you to download today, okay? Mine is C temp, yours might be Z profile. You guys all have different paths out there, but that's what you want it to do, all right? Okay. Name of. Okay, so I'm going to set up a variable right now. I just found this to be easier to do it this way. A string variable called selected selected records. I called mine impacted tracks. So what that is, when we did the part, when we did this part where we did the whole select layer by location, and we had to give it a name, the new selection, and then we exported it out when we did this whole thing, like right click, data, export features. We had to give it a name. This is the equivalent in the code of giving it just a name right here, because you'll see in just a moment we're going to use that name in several places. So I'm not going to hard code a string, and I'm just going to give it a variable name. Okay, it'll make more sense in just a second. All right, so we got that. Save my code. Okay, and now here's what we're gonna use select by location. We're going to have it set up a feature class that gets created as the output of select layer by location. So here's the code for it. Impacted. I'm going to call a new variable called impacted tracks, which is different than the string we just did, and it's going to be equal to ArcPy dot select layer by location management. Whoop. Okay. And by the way, too, like I said, I didn't really mention this, but here's the references for all the most of the code we're doing, and this is really how I did the class today. Here's the official page about what we're doing here, and if you know, and I use these code samples, but so select layer by location. So a couple parameters it's going to have that are needed. This is the part I got mixed up on earlier. So remember, we had something that was coming in. We wanted to know the number of census tracts that are intersecting the hurricane polygon, right? And so here's where all those parameters get plugged in now. And what we do in this, so what we do is we plug in strings that are basically the names of feature classes inside of that file geodatabase. So that's why on line 5 we set that up, because now down here what we want to do is the in layer is, I'm going to type it out, FL census tracks W pop. Okay, that is the equivalent of, okay, so again, I pointed my code at this file geodatabase. Now I'm telling it to go and do the selection using that feature class there. I think I could probably do what I probably could do this too. Just do a rename, copy, paste out of it, and then you know, that'd probably be an easier way to not make a mistake. Nope, nope, not that. Okay, right. And then I need to give it a string, the overlap type, and that's another string you put in. In this case, it's going to be, okay, thanks for the help. I'll use, I want to use single quotes, but intersect, okay. If I go back to the here's the reference on that, right? So that's the second parameter, right? We just did the in layer, now the overlay type, which actually looks to be optional, which is kind of surprising. But so you put a string in this case, I'm doing intersect. Now there's lots of other options. We don't have time to go into every single one of them, but this could be something that's relevant to what you might want to do. So we're going to intersect and we want to intersect with the hurricane cone. So I'll use that little trick there. I'm going to go to hurricane cone, right click on it, rename it, just copy it. I'm not going to actually rename it, and then just click out of it. And then I put that in as my my thing there. Okay. Did you guys all get that? Let me just get to the end. So impacted tracks, ArcPy, select by layer location management, and in verbose English, the first parameter I want to have the census tracts. Argument 1 is a string, that intersect, argument 2 is a string, the hurricane cone, the third argument, also is a string. Okay? And let's just jump around a little bit now. Let's just get the basic thing to work, and then we'll add some variations to it. So I'll save that. Now, right now I'm going to assume that something gets selected, right? And so once this runs, we've already seen it with button pushing, how we got about 1,700 records. So those 1,700 records are going to go into this variable. And let's say now I want to take those selected records. Remember how I did that export? I exported them out into this. So I went from here and exported them into here. To do that in code, we're gonna type this in. We're gonna use ArcPy dot copy features management, and it's pretty straightforward. We're gonna take the telling what's coming in and where it's gonna go out. So in this case, we want to grab the impacted tracks that get created off of line 10, and then we're going to send it out with a name called, we're going to use this, it's in the variable selected records. And that's what that looks like there. And then maybe I'll put a print statement. Okay. So we're even at a point now we can try to run this and see what happens. Okay. Did you guys get that all typed in okay? You see it okay on the screen? All right. Let's run it and see what happens. So before I run it, what I should see happen is, if I set everything up correctly, when I run this code, I should see inside of the file geodatabase I gave you for today, we should see there's currently 3 feature classes. We should see a 4th one pop up called with the name impacted tracks. And so I'm going to clean things up a little bit in here. I'm going to get rid of this one. I'll even get rid of this table for now, right? And let's just run it and see what happens. Maybe I'll do it with a debug mode. I'll save it. I'll go run, start debugging, debug a Python file. Okay, so far so good. It's going to set up the workspace. This is just a string variable. Now here's where some magic will happen. This is where that selection, the query, is going to happen. So it assumes that everything has been set up correctly before. Okay, so far so good. If red stuff starts barfing, let me just get through it and we'll troubleshoot. So I made a selection. I'm going to copy it. So impacted tracks has stuff in it, and then I'm going to keep going. I'm going to copy it, and then good, it's done, and it's done. Now if I go over to ArcGIS Pro, you might not initially see something, but if I right click and do refresh, there it is, right? It wrote a new file, and then if I take impacted tracks, I'm going to drag it over just to look at it. There it is. Okay, so that all happened in a couple lines of code, as opposed to as opposed to using the software to do it. So with that as a first point, any questions or any troubleshooting? Yeah. Oh yeah, the second argument over there was you want intersect. So the first one, and again, if we just talk back in verbose English, we want to select census tracts that intersect the hurricane cone. It is. Yep. Yeah, if you look back at the reference I gave for this one, here's how they do it. It's all uppercase. And if you, I mean, this is how I built the lesson today. I looked at the example code. They have right here, it's, you know, it's an uppercase string. I don't know if you guys remember this. We saw that with the buffer command a couple weeks ago in the beginning of the semester when it was like a dissolve option. It was dissolve all. It was all uppercase. That's just how they do it in ArcPy. Yeah. Any other questions so far?
It's not like finding the data.
Okay.
I wonder if I have it wrong.
Yeah, this is life or death to have this line set correctly, this ArcPy workspace. So if something, it's got to be, the way I did it was a raw string with the full to the directory and then the name of the file geodatabase, hurricane_en_fl.gdb, because this environment workspace is what these other things are feeding off of. That's where it's looking. When you're telling ArcPy to do select a layer, it's going to be looking for these feature classes inside of this workspace. So if that's not right, you're going to have troubles. Okay. Anybody else? Any other? Raise your hand if you got it. If it created the selection and wrote it out. Yeah. Okay. Any other? Any other troubleshooting, or can we move forward with the rest of it? Yeah. It's not able to run? What happened? Okay. Okay, so we ran this code once. We didn't put any error handling in. We didn't do anything. We got right down to business of like copying it out. Now, if I were to run it again, though, if I were to go to run, I'll just run it. I won't debug it. Yeah, so we just had a question, you know, mine ran, it wouldn't do copy features. So whenever you get these errors, try to read them closely. They'll tell you what's going on. Error 725, impacted tracks already exists, right? So there's a couple ways you can handle that. So you run it the very first time, it creates it. Now you can manually go back in there and just delete it out. There's also ways you can check with code if it already exists and delete it. And there's a couple ways to check it. Let's show you how I would do that. There is the overwrite set to true, but just for the learning of it, let's say now once we've made a selection, okay. And with that, you can do a really simple, if statement. So here's this one: if ArcPy dot exists, and this is where I use that variable selected records. So just telling it. So again, I'm going to go in the workspace. Look in the workspace, and there's a handy little thing. If it exists, the name of that. colon, and then it'll automatically indent. Then we do ArcPy dot delete management. Selected records. And again, I just used a variable. I just put the name of that feature class on a variable just in case it changes, because it's the basics of not wanting to hard code strings in for things like names of tables and so forth. And then maybe I'll put just a little comment, a little print. All right. So for this one, I will put I'll put a breakpoint in here and watch it. So now we're just, we got we got right down to business of selecting it, exporting it, but now we're adding some kind of subtleties to it. So in this case, I did I do the selection, and then before I get ready to copy it, I want to just see if it already exists, and if it does, I want to wipe it out so it kind of makes space for the thing that's in there. So like let's see what this happens behind the scenes here. So I'm gonna run it this time in debug. I'll save it. Yeah. Okay. Run. Start debugging. Okay. So we're at line 13. I'm going to step over it. So it returned true that impacted records. So, okay, I want to see if I can see it happen. So right now, impacted tracks is there. I refresh it. Okay. If this works correctly, I should be able to go to the next line. Should wipe it out. So line 14 just ran. If I go back over here and refresh it, it's gone now. I don't know if you saw it, it kind of popped away. So using ArcPy, I went into that workspace, although it's kind of now like a ghost in the map. So it doesn't remove it from the map, but it's gone. I wiped it out. And now I can continue on and do this part and not have it blow up saying that it already exists. Okay. And there it is back again, because so it was already in there. It came along, checked to see if it existed. If it did exist, it wipes it out. And then it continues on and writes a new version of it. And there is another way to do it where you just automatically have it automatically overwrite outputs. However, you never know what you might want to do. You might want to make a copy of it before deleting it or move it to an archive. You have to always think through all the details of what's going on here. Okay. Did you guys get, did you do that part? Did it work? Did it delete it out? They keep getting what error?
I said I got the same error that it already exists, but I can run it in debug. Is this code synchronous, do you know?
Synchronous? Synchronous with what?
Like is it running in a single thread, or is the delete creating a new thread that possibly?
I don't know. I think it's all single. There's nothing fancy like multi-threading. Yeah. Let me show you one more thing, and then we can we'll wrap it up and we can take a few minutes for troubleshooting. Okay, so the last thing I'll show you for today then is that table. Remember I had that little table with the summary statistics. That's going to be one line of code as well, a couple lines. Okay, so in that case, if we go back to the documentation I gave you for today, summary statistics. Again, we saw this tool with its GUI, but we're gonna do the Python version of it. So here's the basic code for it, and then a reference to look at all the things and code samples. The way this worked, if you remembered it, we had to tell it back over here. we took the input table, which in this case was the selected tracks. It's going to write out a new standalone table based on whatever fields you want some kind of statistic. So we wanted the selected census tracts written to a new table, and we wanted a summary of the population field. And that gives us the number, that's 7 million, right? And that's what this tool did for us. But code-wise, here's what it looks like in code. We're going to have a new variable called stats fields, and it's got a somewhat specialized syntax. It's going to be a nested list because depending on how many fields you want. We're just doing a real simple one, really. But we're going to do population, comma, and then sum, okay? And then once again, we use ArcPy with one of its tools or functions, ArcPy.analysis. And it doesn't seem to want to fill in statistics. And again, if you're clumsy like me with your coding, you can always, it's basically this right here. And it's going to take a few arguments here that are, so the in table, the incoming feature class, the name of the table that you want to create, and then the type of the field or fields, and the statistics on that field or fields. And that's why it's a sort of a nested list. So if I had other ones that I wanted to do, you know, I would put them in here and so forth. We're just doing a real straightforward one. So the rest of it's going to be like this. I want to do it on impacted tracks, which, you know, we've seen that a few times. And the name of the table is we're going to give it a name of, how about pop number, the population number. And then we're going to plug into their stats fields. Now you could have, what's the problem here? Oh, I'm sorry, I made a little, yeah. Oh, nope, not that, like that. Okay. Okay, so stats fields is a nested list. And then we plug stats fields, gets plugged in over here. I mean, yeah, you probably could put that whole thing in there. It's just easier for something like this to put it in its own variable, that because especially with this kind of special formatting it's going to need, and so forth. So I'll put a line, I'm going to save this. I'll put a line break in. I'll run it and debug. And this time we should now see a table show up in our file geodatabase called popnum. Okay. And, okay, so again, looking back over here, nothing there now. Now in line 21 on my screen runs, when I refresh it, there's popnum. There it is. It just got written into that file geodatabase. And if I open it, there's the result of that. That's the same as this one here that we did manually. 7 million, about 7,800,000 people, 7,800,000 people. Okay, and that's it. So, so there it is. I mean, it wasn't, you know, 1, 2, 3, 4, 5. You know, the stuff that went right down to business, only about 10 lines of code. I added, there were other things I was going to show you, but I think that's probably good for, that accomplished what I wanted to show you for today. So to summarize, you know, you can do a lot of these kinds of analysis manually with using the software, but it's so much more powerful from an analytical perspective to really start doing it in code, because now I have this code base. Think of all the ways you can expand upon this. Like I said, I didn't go down the road of you guys dealing with like downloading these data sets, unzipping them, cleaning them up, creating the CSV, joining the you know, all of that was taken care of for you, but you could do all of that in code. You could have a thing that runs every day at noon, grabs the newest version of the data, processes it, creates a report, and you're done, right? And so maybe that'd be something you'd be interested in. You could also do some more interesting output reporting. We just had to make a table with a number. You could also check the number of things. You could be going through, you know, when I was deciding how much I wanted to try to do in class today, really there's a lot. I mean, if you even look at, like, for example, one thing that would have been interesting if we had more time in one class period, if I look at the impacted tracks. Oh, by the way, ArcGIS Pro goes weird when you start messing with it with code behind the scenes. Like if we look at the impacted tracks themselves, right? If you notice, like some of them, if I were to just do a right-click sort ascending, some of them have no people. Not many of them, but a few of them. And those are, you know, check out where they are. But look, let me look at that. Like if you had limited time and resources, yeah, they're in the water, right? So in some sense, if you were going to be doing a much more, but look at this one's inland. I don't know what's going on here. I just don't know Florida. Maybe that's like a swamp. Oh, Avon Park Air Force Range. Interesting. You know, but there's no official population there. So if you were doing a very detailed report, you know, where exactly do we need to send resources? You wouldn't necessarily just send to everywhere. You'd have to make decisions about where to go, and if the thing doesn't even have a population according to this, right? So that's the idea of where you would go with the analytics, but you could do all of that in code. It's just then understanding what's available to you through GIS. So in our example today, we looked at a couple different things. We set up the workspace. We selected 2 layers using select layer by location. We did some basic data management to see if it existed. We copied things. We ran statistics on it, all in code. So with that, I did do a screen recording. Were there any questions you guys wanted on the record? Because I may use this in a lab for next week. Hi, this is Brian Tomaszewski. If you enjoyed this video, be sure to like, comment, and share this video. Also, please consider subscribing to this channel and clicking the notification icon to stay up to date on new videos from this channel. Thanks for watching.